This is CCNA1 Chapter 3 Part 2, and we will talk about networking protocols and standards. Um, because we need to have these rules describing how our network will function. And all these rules are designed and set up in different networking protocols, and to make them more easy to understand and also more easy to change, we make a layered model of these networking protocols. And there have been a lot of different types of protocols. Today we are, I think, ending up with one major protocol that we are all using. And it's not just one protocol, it's a protocol suite, and it's called the TCP/IP protocols. And but in general, there have been others before that, and we will have a look at some different types of protocols. In our daily life, we will use these very common protocols, and they are all a part of the TCP/IP protocol suite. It's, for instance, when we are browsing the web and using HTTP protocol. It's the hypertext transfer protocol, which are used for websites and the communication of websites between a web server and a web client. This is handled by a protocol called TCP, which is a transmission control protocol, which takes care of the actual checking and making sure that everything that are sent from the web server to the web client is actually received in the correct order, that it is, if something is missing, then we can resend it. So the flow control part is taken care of, among other things, of the transport protocol. And then we have the IP protocol, the Internet protocol, which takes care of the addressing, making sure that when I send something to, or if I access a website in China, that I actually reach and get access to that web server. So the IP addresses will be routed and sent into the Internet, and are the reason why I can get access to websites all over the world, for instance. The IP protocol is the addressing protocol, where we know where to find things. And then we have the networking access protocol and the data link and the physical layers, which takes care of the actual communication. That when I send something out here on my computer here, it's wireless, but then it will reach the backbone of the school's network, which are a cabled network, and sent out to the internet, which is both cabled and wireless. And all these things all on the physical area. Well, how will my data be sent out on a cable? Well, it's just something about bits and bytes that will be modulated onto a cable. And if it's a copper cable, then it's just sent as intensities of current and voltage. Whereas if I send something out on a fiber cable, fiber optical cable, it will be sent out as light or no light, for instance. So all these things are structured in different types of protocols. And here is a listing of some other types of protocol suites, not only the TCP/IP, but we can see that in one end here where we have the most common protocols. We have the ISO, the International Standardization Organization, which also have made some different types of protocols. We have Apple, which made AppleTalk a very long time ago, and I think more or less have stopped using it. And we had something called Novel Netware, which also made local area networks in the 90s, and they had their own protocol stack for that. But since now we are all communicating more or less with the internet, and since TCP/IP was the protocol stack that we will use on the internet, then we might as well use the same protocol on our local area networks as well. So today we are using TCP/IP on both local area network and intranets and extranets and WAN connections and the overall internet. So this is the one protocol to use. You can see down in the bottom there are these networking access protocols, for instance Ethernet or PPP or ATM or wireless LAN. These are the ones that will take care of the actual communication on the physical layer and the more modulating the data traffic onto which kind of a physical layer that we need to put them on. We all know that TCP/IP is an old protocol because it came actually already, I think it was invented, as we can see here, in 1973. The first, they started to develop the TCP protocol as part of the ARPANET. The ARPANET is the predecessor to today's internet and was made by different universities and research laboratories in the United States. I would like to add, though, that actually there was a company, not a company, but a research lab in Norway, which was a part of the ARPANET already in 1973 as the only research institute outside the US. It's a Norwegian company called Norstat, which is it's a research lab for earthquake and seismology experience and also about some nuclear reactors and stuff like that. But it is important to note that Norway was a part of the ARPANET before anyone else outside the US. But you can see that in 78, not only TCP, but we got the IP protocol, and then more protocols has been added to this suite of protocols. So TCP/IP is an old thing, and we're still using it. And of course, there has been some changes made to the protocol over the years. But the thing with the security issues, that has been a problem. Of course, no one thought about that in 78 and the beginning of the ARPANET. And the whole addressing scheme where we don't have enough IP addresses. We have 4 billion IP addresses overall in IP version 4. And of course, in the beginning of ARPANET, that was really enough. But today we all know that it is not enough. So we need to develop it. And of course, now we have IP version 6, which can take over for that. But here is a listing of the different protocols that we have in the TCP/IP protocol suite. We have the application layer, which is what you as humans and also your applications on your computers will actually know about. This is the interface that will interact with your applications, and that could be, for instance, HTTP, file transfer protocol, FTP and TFTP. We have the emailing protocols, the SMTP, the POP, the IMAP. We have the DHCPs for host configuration, the older version BootP, and we have the DNS, which will translate from domain names to IP addresses and the other way around. So these are the protocols that we are actually aware of. You all know that in your browser it says HTTP, so you actually know this protocol. Then we have the underneath layer, the transport layer, which will take care of the transportation between the different hosts and between the different application on the different hosts. And we have either the TCP protocol or the UDP protocol that takes care of that. And there are a huge difference between these two. And we will have a look at that later on this semester. The internet layer will take care of the addressing in general so that we can go from one network, from one device to another device on another network. So we need somehow to make sure that our addressing is global and that we can send information between all types of networks. But also all the different routing protocols that would take care of this communication for us is placed here on the internet layer. It could be OSPF, it could be BGP and EIGRP and RIP. And there are some protocols that takes care of supporting the IP. For example, it is ICMP, which is Internet Control Message Protocol, which is the one we are actually using when we are pinging. Ping is just ICMP protocol that will send an echo request, and then you will get an echo reply back. And underneath we have the networking access layer, which is typically handled by other type of protocol, for instance the Ethernet protocol. The Ethernet protocol is not really a part of the TCP IP protocol suite, but it will work together with TCP IP. Yep. To handle all these different protocols, we need to have these organizations that takes care of it. Of course, in the old days, we had companies who took care of it, but there was, of course, the problem with interests when we have a company developing a networking protocol. So today, it's handed more or less by different open standards and organizations. For instance, the Internet Society, the Internet Architecture Board, the Internet Engineering Task Force, the Institute of Electrical and Electronic Engineer, IEEE, takes care of a lot about the LAN standards, and the International Organization for Standards, ISO, which will also describe the different standards in internet or in communication in computers. This is just an example of all the different organizations which take care of the internet, because the internet is not owned by anyone, but it is governed and it's ruled by these different organizations. On top, we have the Internet Society. Then we have the Internet Architecture Board, which is divided into two. One, the Internet Task Force. For instance, if we want to develop a new protocol, or if we want to enhance HTTP, it is taken care of by the Internet Engineering Task Force, and we can send in a request for comments if I want to add something or change something. It's also the Internet Research Task Force, which of course will look at newer things. For instance, when you started developing for IP version 6 and stuff like that, it will be taken care of first of all by the Research Task Force, and when they have agreed upon something, it will be sent to the Engineering Task Force to implement it. Then we have the IEEE, which is an organization that takes care of the LAN standards, the different local area network types. And again, here they have a lot of different sub organizations. For instance, the 802.3, which is the Ethernet working group, the 802.11, which is the wireless LAN working group. You probably know that, 802.11. You've probably seen that on your wireless devices, that it will support 802.11g, for instance. And that is just a standard made by the IEEE organization. Yep. And then we have the last one, which is the standardization organization itself, the International Standardization Organization, ISO. And they have made a networking model as well called the OSI model. This model is divided into 7 layers. And this is not a model that you will see working in real life. It is a reference model. So that when we create new networking protocols, we can set up references to the OSI model. We also do that with TCP/IP. It's always referenced to the OSI model because this is the standard. And we might put functionality together so that in TCP/IP, for instance, we only have 4 layers, whereas we have 7 layers here in the OSI model. And it's because we have just put functionality together in TCP/IP so that they actually cover, for instance, the 3 top layers instead of dividing them into sub layers. Yep.